Welcome back to Techify Network. Last time we understood why blockchain exists. We saw that the real problem was trust and that blockchain removes the need to blindly trust one authority. But now, let's learn further. We'll learn what actually happens inside a blockchain, what's going on behind the scenes, what makes it so hard to break. Today, we are opening the engine of blockchain. Let's forget the hype, forget Bitcoin. For a moment, imagine a notebook. Every time a transaction happens, you write it down. That notebook is your ledger. Now imagine that notebook is shared, not copied once, but copied thousands of times, and everyone agrees. Whatever gets written must follow strict rules. That is where blockchain begins. Now let's zoom in. What is a block? A block is simply a container. It stores data. In Bitcoin, that data is transactions, but technically it can store anything. A block contains three important things. First, the data. Second, a unique fingerprint. And third, the fingerprint of the previous block. And that's where things get interesting. That fingerprint is called a hash. Think of a hash like a digital signature, but not handwritten, mathematical. If you change even one tiny detail in the data, the hash completely changes. Not slightly, but completely. And that's powerful. Because now if someone tries to modify a transaction, the fingerprint no longer matches and the network immediately knows. Now, here's the clever part. Each block doesn't just store its own hash, it stores the previous block's hash too. So block 2 contains the fingerprint of block 1. And block 3 contains the fingerprint of block 2, and so on. Now imagine, you try to change block 1. Its hash changes, but then block 2 is now broken because it's pointing to the old fingerprint, and that breaks block 3 and block 4 and everything after it. That is the chain reaction, and that's why it's called a blockchain. Now you might be thinking, okay, but who verifies all of this? Who makes sure that the blocks are valid? The answer is nodes. A node is simply a computer, but not just any computer. A computer connected to the blockchain network. There are thousands of them, sometimes millions, and each one has a full copy of the ledger. Let's walk through it. You send money, that transaction is broadcast to the network. Nodes receive it, they check the rules. Do you have enough balance? Is the signature valid? If yes, it waits to be added to the block. Miners or validators group transactions together. They create a new block, they solve a cryptographic puzzle, and once solved, the block is proposed to the network. Other nodes verify it. If it follows the rules, it gets added to the chain, and every node updates its copy, all at once. Now think about this. If someone wanted to cheat, they wouldn't just change one copy, they would have to change thousands of copies at the same time. They would need more computing power than the rest of the network combined. And that is extremely expensive, almost impossible. That's where blockchain gets its security. Not from secrecy, but from math. This agreement process is called consensus. It simply means the majority decides what is valid. If most nodes agree, the block stays. If not, it gets rejected. No central authority, no single boss, just distributed agreement. Now let's step back. What did we just build? A system where rules are enforced by mathematics. Verification is distributed. History cannot be quietly rewritten, and trust is built into the architecture. That's what is happening inside a blockchain. But remember, this doesn't make blockchain perfect. It can be slow, it can consume energy, it can be inefficient for small systems, but when trust is weak and transparency is critical, it becomes powerful. Now you understand the engine: blocks, hashes, nodes, consensus. But in the next video, we will learn even further. How does mining actually work? What is proof of work? And why does it require energy? Subscribe to Techify Network and let's understand modern technology from the basics.